next part itself, you'll notice that this part overlaps quite a bit with your geography itself. So if you have studied and you still remember some of your geography itself, you can actually make use of it. This part is more less commonly tested, very not very commonly tested itself, mostly in your MCQ. However, this one have to link it with your real world application itself. Why are we even learning energy in the first place? Because some of you may be asking, Icha, why are we even learning physics itself? We're not going to use it in your real life or day-to-day life itself, right? However, this portion or this subsection itself will actually link it all the way to your real-world application itself to a very large extent. Okay? So first things first, you want to talk about energy resource. Energy resource usually refer to any kind of resource that's in nature that we can tap into it. And mainly there are two different types. You have your non-renewable and you have your renewable itself. So usually if we want to talk about which one is the better one, we always talk about efficiency, cost, and environmental impact itself. So when we talk about efficiency itself, how much can be the useful energy that we tap into? When we talk about costs, we don't only talk about monetary costs, we also talk about your risk to life, your waste management, your cost of transferring here and there. All these little things can be costs. Like what is the disadvantage, or basically what do you need to do first before you can actually tap into your energy resource. For reliability itself, it is talking about 24/7. Can I use it for 24/7? And environmental impact is very straightforward. Does it damage the environment? Does it affect the ecology around it? Does it kill the flora and fauna? What happens? Okay, global warming and stuff like that. It's not a myth. Okay. Next page, non-renewable energy resources basically are resources that once you use it up, they will be gone, consumed, depleted, gone, zero. Okay? So if you keep burning fossil fuel, one day we'll run out of fossil fuel itself. So because of that, you will actually notice that a lot of countries have been switching to renewable energy resources, like China and Germany, if I'm not wrong. These are the two forefront runners who have been using more and more renewable energy resources rather than burning coal and fossil fuel itself. Okay, so you can take note of this. Basically, how this works is when you burn fossil fuel itself, you actually turn a turbine, and when you turn the turbine itself, you do produce electricity, which is what you learn in actually your second or last chapter itself. Okay, the next one is talking about uranium, which is actually your radioactivity itself. So nuclear reaction, nuclear fusion, nuclear fission itself, same thing. Because I produce heat, I can turn generators. Okay, next one is your renewable energy resource. You need to know how to explain it. Is that they can naturally replenish themselves over time, and not replace, replenish be a better word. Okay, themselves over time, and they will not be depleted. So like your rain, like your wind, we can't use up the sun, we can't use up all of those, right? Now for biofuel itself basically means we plant them. So if we plant more than we burn, then this is considered to be renewable. However, if you burn more than you plant, then that's not very, very renewable itself. And we don't always just plant them and just burn them straight away. For example, like your sugar cane, we actually squeeze out all the sugar cane juice first so that we have the sweet drinks. And then after that, with the leftover fibers left, we can actually burn it to actually to generate electricity. So same thing, when you burn it, heating effect, motion, generator turn. Next, for your wind itself, your wind will actually turn the turbine, and because your wind is moving energy, you will actually have motion. Same thing with your tides, as well as your hydropower electric dam. Now, for geothermal reservoirs itself, if you play your video games or play Genshin itself, you know that geo means earth, thermal is heat from the earth. So basically, we just pour water into a very, very deep hole, and then because the center of earth is so hot, it can actually boil the water, and when the water boils itself, it actually allows us to turn the turbines with that. Okay, the only one that doesn't really involve any kind of turning itself is actually your solar energy cells. So your solar panels, your solar whatever that you have, basically they can increase the chemical potential energy store just by being exposed to sunlight itself. Okay, so do take note about all of this. So in the next pages itself, we're going to talk about the efficiency, the cost, the reliability, and the impact that you have. Now, I want you to highlight low efficiency, right, whenever you have any kind of burning. These three involves burning. So anytime you have anything that involves burning or heat, there will always be low efficiency itself. Why? Because anytime we burn or heat up something itself, there will actually be quite a bit of energy loss. It's actually a lot of energy loss, right? If you remember just now, there was one question about the vehicle, the car itself. Just a normal engine itself is only 20%. So you can just imagine 80% is actually wasted. So because of that, you actually have very low efficiency whenever you have anything that have burning itself. However, burning has its own perks. What do I mean by that? It will always be high reliability because all you need to do is just start a fire. You can just literally burn your fuel, you can burn your petrol almost just instantaneously. Oh, anytime I want to burn it, I just burn it, no problem. Okay? And because the technology is already there, we have already built the facilities, we have already built all your power stations itself. Basically, we can just use and burn it with no problem itself. And because of the current abundance of fossil fuel and whatnot, basically it's very cheap itself, so we can just burn it, no big issues. However, anything that involves burning will always cause air pollution. And for this, you produce radioactive waste, air pollution itself. Okay, so all of these are actually all very, very dangerous. Now, if you notice for biofuel, I said that it's actually medium impact and instead it's not high impact, even though it's high pollution, because when you plant, plants photosynthesize. And when they photosynthesize itself, they reduce CO2. So when they reduce CO2 itself, you can think of it as it mitigates the impact itself, so it's not as bad because you are planting more trees to help you counter the global warming itself. Alright. The next one's for those that don't involve any kind of burning itself, you will always have low impact itself because you don't actually cause any kind of pollution. You always will just basically just generate electricity based off what you have. You don't actually produce any kind of waste material itself. Now for the efficiency wise, it really depends because it depends on the type. Are you talking about wind? Sometimes in Singapore itself, we don't really have very, very strong winds, right? Unless you are in those kind of high-rise buildings itself. But because Singapore's have flats, we have skyscrapers, we actually block out the wind. So for you to have enough wind to be able to turn turbines properly, it's not very, very efficient because Singapore's wind speeds are actually quite low compared to other countries itself, where they have very large open space. Okay? Then same thing, reliability really depends on the weather itself, but for tides it's okay. But in terms of Singapore context itself, we can't really use tidal energy. Why? Because number one, we do have sea space, available sea space for building this kind of setup. If we go a little bit further, we are in Malaysia's waters. If we go further, we go Indonesia's water. So we can't really do tidal energy, any kind of construction itself, because they may also block the path of our boats, our ships that's coming in and promoting a trade in Singapore. See, so hydroelectric dam as well, high efficiency because basically all I need to do is just block the water, open the water, let it flow, turn it, no problem. Okay, high reliability, especially in Singapore because it rains very, very often, is actually quite a feasible idea. Unfortunately, Singapore's waters and rivers are too low-lying to build a dam. The only thing we have closest to a dam is Marina Barrage, which only is able to power up the museum right next to it. It won't be able to support the whole of Singapore. Alright, then for geothermal itself, usually this is for bigger countries, but in Singapore we do have a geothermal reservoir, but it's mostly a very small area. It can only like first serve as a small hot spring to cook eggs and stuff like that in Sembawang area, if I'm not wrong. Okay, not very, very good, but it's usually high reliable because the earth, the inner part of the earth is always hot. Okay, and solar cells are actually two different types. One for using light to produce electricity. One is just to use the heat from the sun to actually heat up your water heaters and stuff like that. So to take note the different types. Okay, so and really depends on the time and day. So for example, Singapore hot and humid, usually we have quite a lot of clouds in the skies. So you have a lot of clouds, your efficiency and reliability is actually quite low as well. So it really, really depends on the current technology. As technology improves, then you will see more better improvement and changes to all of these efficiency, cost, reliability, and impact itself. Okay.